Hello everyone from Math 1340, Statistics. It's Professor Wenson here with a video on Section 2.3, Measures of the Location of the Data. And this time, in a lot of the first videos I showed you, hey, if you're on Canvas, click on this page to open up, the OpenStax book for Section 2. Whatever, and Alright, so hopefully by now you know where all that stuff is, what the pages on Canvas will look like for every section. So from here on out, I'm just going to be going over the KnewtonAlta homework. Alright, so I'm just going to start off right away in a preview of what you're going to be seeing in KnewtonAlta. So there's a section 2.3, Measures of Location of the Data. Alright, so again, you have your title, mastery bar, the objectives, and your progress on those objectives. All right. Okay. All right, so the first objective is finding the median of a set of data. The median of a set of data is like a value that's directly in the middle of the data when you put it in order from least to greatest. Now, if you've read through OpenStax section 2.3 and you've also watched the videos I put up in the Canvas page, if you've done all that and you've practiced some stuff, if you feel comfortable with the material, you can start answering questions right away here. But as I've been mentioning every video, I would recommend, every time you see a new objective, click on More Instruction and work through the homework that way. All right, so finding the median of a data set. So another measure of the center of the data is the median. The median is a value that divides the data set, the observations in a data set, so that 50% of the data are on its left or below it, right? And the other 50% are on its right or above it. Note the median is generally a better measure of the center than the mean, say. We'll talk about the mean in future sections. The median is a better measure of the center when the set of data has extreme values or outliers, because it is not affected by the numerical values of these outliers. All right, so how do I find the median of a data set? Well, they break it up into two cases. Finding the median with an odd number of data values, right? So if you have like 7 values, 15 values, 19 values, right? Some odd number, not 12. The median of a set of sample data for which there are an odd number of data values is the middle measurement when the values are arranged in numerical order. That is the key. All right, they have to be arranged in order from least to greatest. So their example here, given the set of data, what is the median? So here's a set of data, all these observations. There are 11 observations, an odd number of data values. So they rearrange in least to greatest, right? They put these 11 numbers in order from least to greatest. And 11 values, the median will be the one that has 5 below it and 5 above it, right? 50%, it cuts the set in half. So you see how it's 41 here, how there are 5 below and 5 above, right? So the median, when there are an odd number of data values, is just the value in the middle, right? So the median of this set is 41. When there's an even number of data values, you're going to take the average of the two middle values after you rearrange them. All right, so the median of a set of sample data for which there are an even number of data values, so 8, 10, 12, etc., is the mean, right, the average, add them up, divide by 2, is the mean of the two middle measurements when the values are arranged in numerical order, right? So their example here, here's a given data, here's a data set that has 10 values. That's an even number. There are 10 values in the data set. First, you order them in numerical order, least to greatest. And then I want to cut it in half. I want a value that has, again, 5 below, 5 above, but that'll be halfway between the middle two, right? So you see 5 and 6 here. Those are the middle two values. And then what's the average of 5 and 6? 5 plus 6 is 11, divided by 2 is 5.5. So you see 5.5, 5.5 would be considered the median. If you put 5.5 here, you have there are 5 values below 5.5, and there are 5 values above 5.5, right? 5.5 cuts this set in half. Just like how 41 kind of cut this set in half. You have 5 below, 5 above. All right. So let's work on a problem. And I'll also show you how you can do this on your calculator if you want. So given the set of data, what is the median? All right. Now you could arrange it. Now there aren't that many values here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 values, right? So there's an even number of data. So first I'm going to rearrange this in order from least to greatest. All right, so I'm going to do that on paper and bring up a paper in a second. Okay, so I've pulled up here. I've just taken those numbers and I did this by hand. All right, just rearrange those same numbers in order from least to greatest. All right, and then there are an even number of values, right? The number of values here, which I'll call n, is 10. Right? Usually n will represent how many data values you have in a data set. That's an even number. Right, that is an even number. So the median is the average of the middle two. Right? So what are the middle two? Right. Well, to cut this, there are 10 values. To cut it in half, I need to take the first 5 and the last 5. That cuts it perfectly in half. There's where the median is going to be. Right? 5 below it, 5 above it. So I'm going to take the average of these two values. These are the middle two values, 80 and 88. So I take 80 plus 88 divided by 2. What's exactly halfway between 80 and 88? That'd be 84. All right. So the median value of this data set is the number 84. Right, so I take that out here, and I'll punch this. It's just a multiple choice there, 84. Now, I'll also show you how to do this on your calculator. Again, I'm pulling up the TI-84 here. So I'm going to just enter a list of data, or I'm not going to have you watch me do that. I've done this plenty of times. So I'm going to come back when the list is entered. Okay, so I've got my calculator up here now, and you can see I've entered those 10 values from the screen down list 1. Now I can do this in the long way to do this would be to rearrange them in order. Go stat, go to sort in ascending order, and then I'll sort list 1 in ascending order, and then go back and look at the list. And you see now it's in order 59, 64, 67, and so on. This is exactly the same order I wrote out earlier. And then what are the middle two values? Those would be the 5th and the 6th value, right? 80 and 88. And what's the average of 80 and 88? That was 84, right? So I could have done that, or get out of here. You can have the calculator, find the median of a particular set of data for you. If I have a list of data above the stat button, you see it says list. You can do a lot of things with your lists of data in this list menu. You go to list and then over to math, and then you see down number 4 it says median. I hit enter median. What's the median of? And then I go second number 1 and put L1, list 1. Right, all my data was down list 1. What's the median of that list 1? And it should be 84, as we saw by hand earlier as well. Okay, so 84 is the median. Great. Moving on. All right, another one. All right. this one has 9 values, an odd number. The International Shark Attack file recorded the number of shark attacks between 1837 and 2016 for 9 different U.S. states. What is the median number of shark attacks over these states? All right. So again, I'm going to rearrange these by hand, or you could again enter it in your calculator, have the calculator do it. It's fine, but I'll pull it up when I'm done writing. Okay, so here are these same 9 numbers written in numerical order, in order from least to greatest. We would say that n equals 9 here, the size of the data set. There are 9 values. So what's this is an odd number. All right, this is an odd number of data values, and when it's an odd number of data values, the median is simply the value in the middle, the middle recording. So that would be this value right here, right? Because there are 4 below it, 4 above it, right? The value with exactly as much below as it is above, that's the median. So let's put MED equals 4, and it's that simple when there's an odd number of data. And again, you could enter that as a list and have the calculator do it if you wished. Right. So, and then this one's a fill in the spot here. Right. So the number 4 is the median. So again, hopefully pretty simple to find the median. Right? Just got to pay attention to whether or not there are an odd number of data or an even number of data. All right, so I have another set here. All right, so this time I'm just going to go to the calculator. I'll pull that up when I'm finished, when I enter this list. Okay, so I've got this list entered, and like I said, I'm not. I can now, since the last thing I entered was the median of list 1, I can just re-enter that by going second entry. Entry just enters the last thing you put in. And what's the median of list 1? This list is 16. All right, and there was an even number of values, right? There were, if you count them out here, there were 10 values. So it was the average of the 5th and 6th value in order, right? Not these orders, not this order, but in the order from least to greatest. And the average of the 5th and 6th would be 16. All right, so back here, filling in the blank 16 minutes there. Okay. Again, they show you rearranging it in order. That would be the average of 15 and 17, right? These middle 2 values. All right, so let's continue on. All right, and this is the same thing. Find the median of the following set. So I'm not going to do this one. I'm just going to hit instructor cheat, have it fill it in for me, as you know how to do this. I've already done this several times now. All right, so the median amount would be 24. All right. And again, they go through the explanation here. Great. Right, so done with that first objective, just simply finding the median of a set of data. Right. Continuing on. This objective is, identify the interquartile range and potential outliers in a set of data. All right. Okay, so I click on more instruction. It's a new objective. Interquartile range. Now there's a video. I'm not going to watch the video. The interquartile range for a set of data. It's useful for identifying outliers. A number that indicates the spread of the middle half, or the middle 50% of the data in a data set. The difference between the third quartile and the first quartile. All right. So let me show you how to find, on a piece of paper here, how to find these quartiles. All right, and this is actually part of another objective, so when I go over this. In fact, what we're going to be finding things called percentiles first. Finding percentiles. Now, you might have heard the word percentile before. When you take a standardized test, when somebody says that you scored in the 75th percentile, that just means your score was better than or as good as 75% of the students who took that test. So when you say something is in the kth percentile, that means a value that is better than or equal to, that is above k percent, that is above k percent of the data values of the data set. So an example, say my data set, and I'll put it in order. You have to arrange things in order from least to greatest. I'm just going to put it simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, let's say that n equals 11. All right, the number of values in the data set is 11. Now you can find the median pretty easily, right? That would be just the number 6. Right? There's 5 above, 5 below. But say I wanted a certain percentile. If I asked you for, if I said find the 30th percentile. Right. So here's what you're going to do. All right, to find a kth percentile, and this will come up later in the last objective. You're going to do this. Take k over 100, right? Because that's a percent, right? So 30% in this case. K over 100 times. So I find k over 100 times, and then n plus 1. All right, where n is how many values there are. If this is a whole number, all right, so if whole, right, if a whole number, then that position, that position's value in the data set list is the kth percentile. If it's not a whole number, so like 2.3 or something, then the kth percentile is the average, the average of the values in positions around that non-whole number, right? Of the values in positions around this number, around this non-whole number. All right. So for example here, all right, this list 1 through 11, I say find the 30th percentile. So take 30 over 100 times 12, right? 11 plus 1. All right, 11 plus 1. This is 3.6. All right, this is 3.6, not a whole number. All right, not a whole number. Now, what is 3.6 between? Right, what whole numbers is it between? This is between 3 and 4. So that means the 30th percentile. Right, the 30th percentile is going to be the average of the third and fourth number in the list, right? And this is in order, right? This is in order, in numeric order, which this already is. This is already from least to greatest. So I go, what's the third number? 3. What's the fourth number in order? 4. So what's the average of 3 and 4? 3 plus 4 divided by 2. All right, 3 plus 4 divided by 2. That's 3.5. All right, so the 30th percentile of this data set, they would say, is the number 3.5. Okay. So that's how you find percentiles, as one example. We'll see more later, because this is actually going to be the last objective. Now, they mention the word quartile. Quartiles are percentiles. Quartiles are just every 25th percentile. So you have what's called the first quartile is just the 25th percentile. And the way I would find this is exactly like I did up here with the 30th. Right. The second quartile is the 50th percentile. Now another word for this is the median. The third quartile is the 75th percentile. And then this interquartile range that's mentioned is the difference between Q3 and Q1. Interquartile range is Q3 minus Q1. It's like the middle 50%, right? The difference between 75th and 25th percentiles. It's the middle 50% of the data. And this is referred to as IQR for interquartile range. Right. All right. And then one last thing about outliers. Well, I think they might mention that in later instructions. So let's go back to the website. Now that I know what these quartiles are, right, how to find them, let's continue. And we're asked to, here we're given a data set. The data set below contains the average low temperature in April for 9 Alaskan cities. What is the interquartile range, or IQR, of this data set? All right, so here's how you do this. So now notice this is already in order. It's already in order from least to greatest, and it should be. All right, and if it's not, you have to make it, from least to greatest. Rewrite it from least to greatest. All right, so I'm going to pull up. I'm going to write these numbers on my paper, and we'll do that on a separate sheet of paper. Okay, so here were the values that were mentioned. 5, 12, 14, 19, 19, 21, 25, 29, 33. So n equals 9 here, right? The number's 9. I'm going to, if I want to find this interquartile range, I need to find what are called, again, the third quartile and the first quartile. So the third quartile, all right, is, again, the 75th percentile. So remember how I found this, right? As I find, K here is 75. 75 divided by 100 times n plus 1. So 9 plus 1 is 10. What is this number? Now, that's just 7.5. All right, that's 7.5. So that means that Q3, all right, this is not a whole number. 7.5 is between 7 and 8. So Q3 is the average of the 7th and 8th values when they're written in order. All right, so what are the 7th and 8th values? And these are already written in order here. 1, 2, 3, 4, 5, 6, 7, and 8 are 25 and 29. So 25 plus 29 divided by 2. All right, now that's 40. That's 54 divided by 2. That's 27. All right, so the third quartile is 27. And then I can do something similar for the first quartile, right? Q1. Now the first quartile, right, the first quarter of the data there, that's the 25th percentile, right, first quarter. And I find it in exactly the same way. I find instead of 75 over 100, I'm doing 25 over 100 times n plus 1, right? Times 9 plus 1 times 10. So this is just 2.5, not a whole number, right? Not a whole number, but that is between 2 and 3. So Q1, the first quartile here, is the average of the second and third. Right, it's the average of the second and third values in this data set when it's in order. All right, now what are the second and third? That's 12 and 14. What's the average of 12 and 14? That's 13. So the third quartile, the 75th percentile, is 27. The first quartile, or the 25th percentile, is 13. So this interquartile range, right, IQR, is 27 minus 13. It's just the difference between Q3 and Q1, and that's 14. All right, so the difference between the 75th percentile and the 25th percentile is 14. All right, so I'll go back to the website here and just provide your answer below. Just it's 14. Now, there's a very easy way to have you can have your calculator do this as well. All right, so what I'm going to do is I'm going to enter this list of data, the same list, in my calculator, and show you how to get these quartiles show up to you on the calculator. Okay, so I've entered now on this calculator down list 1. You see I've entered these 9 values. So if I get out of here and clear that, you can have the calculator bring up a lot of numbers related to a list, not just the median. So if I've got, I got this list of numbers here in list 1 in my calculator. All right. If you hit the stat button, go stat, and then move the cursor over to calc where it says calculate. Now I only have a single list of data, L1. So I'm going to hit enter on that one var stats number 1 there, enter. And then it says, hey, what list? Well, list L1, it's already there. There is no frequency list. We're not going to talk about that just yet. We'll do frequency lists later. And I hit calculate, and a bunch of stuff comes up. Now, a lot of these numbers we don't need. The first one's actually the average. If you add up all 9 numbers and divide by 9, there's 19 2/3. See how n equals 9? That's how many there are. All these numbers in between we're not going to get to just yet. Scroll down. That's the minimum value, right? You see the lowest value is 5. You can see that in the list on the page. Then you see that Q1. That's the first quartile, right? Which I found was 13, right? Median, right? That's what MED is for. The median is 19. Then you have Q3, which is 27, which again I showed you earlier. Q3 was 27. And then you have the maximum. All right, and that's it. But you're seeing the Q1, the first quartile, 13, the second quartile, the median, 19, and the third quartile, 27, the 75th percentile. And the interquartile range is simply the difference between Q3 and Q1, 27 minus 13, or 14, as we stated earlier when I did it by hand. All right. Again, not too crazy to find. All right. All right, now we're talking about outliers. Now you've heard the word outlier before.
In this video, we want to...
Outliers are just numbers that are either way too big or way too small. You know, they don't fit with the rest of the data. So you have a lot of, say you have a lot of numbers around 25, and then you see a number that's 1,000. You know, like numbers that are way outside the normal data. Now, how do I determine if a number is an outlier? What are potential outliers? All right, so I'm going to go back to my paper here, and we'll talk about potential outliers. All right. That stuff out of here. All right, potential outliers. So here's here's a representation of a data set. Here's, say this is where the first quartile is, and say this is where the third quartile is on a number line. Remember the difference between these two, this distance here, the difference between them is called the interquartile range. I just said that, Q3 minus Q1. If you take this interquartile range and add it, I add the I'm sorry, not one of it, but 1.5 of it. Sorry. No, it's not looking perfect here, but if I take the third quartile, take Q3, and then add to it 1.5 of these interquartile ranges, and then do the same thing on the other side. Take Q1, take the first quartile, and subtract 1.5 interquartile ranges. So we have Q1 minus 1.5 IQR over here. Anything outside this, all right, anything over here, anything outside there could be what we'll consider an outlier. Anything greater than Q3 plus 1.5 IQR, or over here, sorry, it's a bad drawing, but outlier, right? Anything less than Q1 minus 1.5 IQR. So these are important numbers. Take the first quartile minus 1.5 interquartile ranges. Take the third quartile and add 1.5 interquartile ranges. And if anything's greater than this one or less than that one, you have a potential outlier. All right, so back here. Now this is the same set of data. All right, this is the same set of data, 5 to 33 here, that I had in the previous problem. And let me show you what we got here. We got all right, here's what we had. All right, put them in order and all. Oh, they were already in order. We found the third quartile was 27, first quartile was 13, and the interquartile range was, the difference, 14. So now to determine potential outliers. I'm going to take the third quartile and add 1.5 of the interquartile range. So that's 27, right, the third quartile, plus 1.5 times the interquartile range was 14. All right. So that's 27 plus 21, that's 48. Are there any numbers in this list greater than 48? No. All right. 33 is the highest. So there aren't any numbers greater than Q3 plus 1.5 IQR. Then I take the first quartile, right, on the other side, the 25th percentile, and I subtract that same value, 1.5 IQR. Now the first quartile was 13, and I subtract this 1.5 times 14, 1.5 times the interquartile range. So that's 13 minus 21, would be negative 8. Is there any value less than negative 8 in this list? Well, no. The smallest value is 5. So based on these two numbers, there's no number greater than 48. There's no number less than negative 48. So there are no potential outliers. There's no numbers that I would consider too far away from the rest of the data. All right. So back to this. Yeah, so no potential outlier based on that criteria. Right. Again, they do the explanation with the Q1 minus 1.5 IQR, Q3 plus 1.5 IQR, and so on. All right, so now we're getting to, now I already discussed this one, all right, a little bit, this objective. This was the finding percentiles and quartiles. And I described that to you here. All right, where if I want to find the kth percentile, I take k over 100 times n plus 1. If it's a whole number, great, just go to that position when you rate it in order from least to greatest. And if it's not a whole number, as we've seen, you go to two positions that's around that and take the average. And it's that simple. All right, and then quartiles are just every 25th percentile, as you saw, right? The first quartile is the 25th percentile. You use 25 over 100. The median is the 50th. That's the second quartile. You can do 50 over 100 if you wish. And then the third quartile is the 75th percentile. You do 75 over 100 times n plus 1. It's all the same. All right, so here, the following data set. So this is, more instruction to show you the formula and all that. All right, it's a new objective, so I'll go to more instruction. And it explains, I think there's a video here, percent on percentiles. I'm not going to watch that. You can watch that. All right, percentiles. I haven't read definitions yet to you. Percentiles, a common measure of location, where a piece of data is, right? A location of data values within a set, mostly used with very large populations, and useful for comparing values, calculated by ordering the set from least to greatest and dividing the ordered data into hundredths. Right? That's what the divided by 100, right? Percent. Quartiles. These are special or more specific percentiles, right? The 25th, the 50th, and the 75th, that divide ordered data into quarters, right? And they may or may not be part of the data depending on the number of data values, right? And I showed you how to calculate them. So let's do that here. So we're given in this question, the following table summarizes 60 data values. So n, right, the number of values is 60. What is the 80th percentile of the data? And it says read from left to right. They put it in order from least to greatest for us, which is nice. 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 6, 6, 6, 7, 7, 8, 8, 8, 8, 8, 9, 9, 9, 9, and so on. It's least to greatest going left to right as you go down. So it's already arranged from least to greatest. That's fantastic. And let me pull up my paper here. And let's find, now we're told we have n equals 60. There are 60 values. All right, n equals 60. I want to find the 80th percentile. Now, sometimes this is in some books referred to as like P with a subscript of 80. You'll see P for percentile and then the number underneath, like this is the 80th percentile you might see in some texts. All right, so that means K is 80, right? I'm finding the 80th percentile. So first I find what's 80 divided by 100 times n plus 1, so times 61. Right. Now 8 times 61 would be 488. So this is 48.8 when I'm all done, right? And you can punch in a calculator if you want. That is not a whole number, right? That is not a whole number. But it is between 48 and 49. So this 80th percentile I'm looking for is going to be the average of the 48th and 49th values. So we got to find what those are. All right, so what are the 48th and 49th values when they're in order? So we have, 5, 10, 15, 20, 25, 30, 35, 40, 45, 46, 47. The 48th and 49th values are both 17. All right, they're both 17. So this is, 17 plus 17 divided by 2. That's just 17. I mean, they're both 17. So the 80th percentile is the number 17 in this data set. And unfortunately, your calculator doesn't find percentiles like this. You're going to have to do it kind of the long way. There is no percentile feature. There's quartiles, right? You saw the calculator can do quartiles, sure. But I haven't seen any percentile features on the calculator. Right? And again, they go through the same explanation that I just went through. Right? Got the 48.8 and all that. Great. All right. And then they talk about quartiles here, just bringing it up to you that quartile means 25th, every 25th percentile. All right. So just do the same thing I just did, but instead of 80, it's going to be 25, 50, or 75. So I continue on, and here. So, the following table is, so it's the same table of data. Same table. 60 values. What is the third quartile? Not third percentile, right? Be careful. If they said, what is the third percentile, then you're doing 3 over 100. Third quartile is what I do the following. Right? So again, we have n equals 60. Right? We're finding the third quartile. Now the third quartile is the 75th percentile, P75. So I'm going to find, what's 75 out of 100 times, and then n plus 1 times, 61. All right, now 75 out of 100 is just 3/4, right, just to make that a little easier. And then, 3 times 61 be 183 divided by 4. This is 40 something. All right, yeah, this is 45.75, I believe. Check me on that. All right, now again, not a whole number, but it is between 45 and 46, right? So the third quartile is going to be the average of when you write them in order from least to greatest, average of the 45th and 46th values. And let's see what those are. All right, so let's go back. Let's find the 45th and 46th values. So this is 60, 55, 50. Here's the 45th value, 18, and the 46th value is also 18. All right, so this is just 18. All right, this is just 18 plus 18 divided by 2, just 18. Right, they're both 18. So the third quartile is the number 18. Now again, now this would be kind of horrible to write in. I would say, we're not going to have to enter too many lists in our calculator that, more than 30 values long. I would not enter this into a calculator. All right, that would take way too long. 60 values, that's a lot. I mean, you could do it. All right, you could do it. I think the calculator does hold that much data. It's just, it'd be annoying. And it's already put in order here for us, so we can just very simply find it. And the third quartile is the number 18. And again, they go over the same explanation. So yeah, quartiles are just percentiles, just 25, 50, and 75. All right, so here, now the second quartile, that's the median, right? You use 50%. So I'm just going to leave this to you. Now this is a different table, but it's still 56. There are 56 values here. So n is 56. N is 56. You take half of that, 50%. Well, actually, half of 57, right? N plus 1. Half of 57, right, is 28 and a half. All right, so you do the average of the 28th and the 29th values. So 5, 10, 15, 20, 25, 26, 27, 28, 20, that's 38. The 28th and the 29th values are both 38. So the second quartile or the median are both the number 38. Right, that's the average of 38 and 38, right? All right, then I think there's one more, which I'm just going to do the instructor cheat on because it's the same stuff. 80th percentile again. So just pay attention to if the word percentiles in there or the word quartiles in there, and also pay attention to how many values there are, and make sure they're in the correct order. Make sure they're in order from least to greatest. If you were to do this, find the 80th percentile of these 50 values. It looks like it would be 77, right? Probably these two here. Right? Take 80% of 50 and or 80% of 51, right? Take 80 over 100 times 51, and then that'll give you positions to go to. All right. So I got 2 or 3 objectives done, and then the last one's on the, we're going back to that outliers section, the outliers objective. All right, so back to, I think I got maybe a couple more problems here, where you're finding the interquartile range and potential outliers, right? All right, now the 5 number summary, this will be talked about more as well. The 5 number summary are what's given to you by the calculator as well. The lowest value, the first quartile, the second quartile or the median, the third quartile, and the maximum. What is the interquartile range of the set of data? Well, that's simple. Remember, it's Q3 minus Q1. So 80 minus 70. 10, right? The interquartile range is 10. Simple as that. And then use the interquartile range. Using the interquartile range, which of the following are outliers? Select all correct answers. All right, so again here, I'm going to pull up a piece of paper and write this out. Now we're given the 5 number summary. We're given the smallest value, the first quartile, the median, the third quartile, and the largest value for some data set. We don't know all the data, but we see the largest and smallest in all the quartiles. The interquartile range, remember, is again Q3 minus Q1. In this case, it's 98 minus 84. That's 15. Right? The interquartile range is 15 units long. Now for potential outliers, I find 2 values. One is Q1 minus 1.5. Go on the low end, go Q1, and then go even lower, minus 1.5 interquartile ranges. So this would be 84 minus 1.5 times 15. All right, 1.5 interquartile ranges. Now this would be 22.5. All right, 84 minus, this is 22.5 here. So 84 minus 23 would be 61, but then plus a half, this is 61.5. So anything below, right, anything below 61.5 would be considered a potential outlier. All right. And then for the upper end, I go to the right quartile, the Q3, and then add 1.5 interquartile ranges. So Q3 in this set is 98, and then adding 1.5 times 15, or again 22.5. And this would be 120.5. Right. 98 plus 22.5. Anything above this would be considered a potential outlier. So looking at my chart, looking at the assignment here, the number 6, this is too small, right? This is less than this Q1 minus 1.5 IQR. So 6 would be a potential outlier if it was in the data set. In fact, the smallest value is an outlier, 5. Right? 42 would also be a potential outlier. Right? 42 is less than 61.5. anything in this range is fine. Anything below this is an outlier. Anything above this is an outlier. 97 is within this range, so not unusual, not a potential outlier. 111 is in this range, so that's okay. 116 is in this range. So the only two values in this list that it could be considered a potential outlier or an outlier, something that's very far away from the set of data, the bulk of the set of the data, are the numbers 6 and 42. Right, and again, they go through the same explanation I did down here. Oh, wow, I can't subtract. I mean, we were still correct. Yeah, 98 minus 84 is 14. Wow, so this would be 14, this would be 21, and this would be 63, and this would be 21 here, and this would be 119. But it's still the same numbers. I lucked out. So from 63 to 119 would be okay. Anything less than 63 is an outlier. Anything greater than 119 would be considered an outlier. My goodness, right? So make sure you're doing your arithmetic correctly, folks. That's a good lesson there. All right, and then continue on. And I think that's it for this this section. Wonderful. All right, so I hope this is a good guide. Again, you're not going to see exactly the same order or the same problems I am, but the objectives are the same. The way you do them is the same. So hopefully this is a good guide for you, a good lecture video. And thank you for watching. Let me know if you have any questions, of course. And thanks for watching.